This is 2.7, Piecewise Functions, Day 1. Before we get started, we're going to do a little warm-up on something we worked on in our last section. Transformations of parent functions. So here we have the square root of x. Remember, this is the function that looks like half of a sideways parabola if we were to graph it. But all we want to do right now is just identify the transformations that are happening. So go ahead and hit pause, see if you can figure out everything that happened, and come back and check. This negative on the outside reflects over the x-axis. And then the minus 3, this part right here, is the inside the square root. So that's our h value. Our h value is always the opposite. So even though it's a minus 3, it actually goes to the right 3. And then the plus 4 is our k value. It's on the outside, and that tells us that we would go up 4. So 3 transformations on that one. All right, so today we get to use our knowledge of these parent functions that we've been working with to graph multiple functions on the same graph. We're only going to be doing pieces of them, so not the whole function, which is why these are called piecewise functions. So after we graph, we will then also identify the domain and the range. All right, so as you look at this, it's important to know that there's kind of 4 different parts here. We have function number 1 and the domain in which we're going to use it. Function number 2 and the domain that will use it. So on the left are the 2 functions, and the right tells us when we're going to use them. This first function, hopefully you can identify, is just a line. It's linear. There's no squares, square roots, cubes, anything like that. So we want to find points that will be on that line, and we're going to use this domain to do that. So we want to start at -2 and then find some points until we get to 1 and stop. So if we substitute those into that equation there, -2 times 2 minus 1, we get -5, then -3, -1, and 1. Now, because these were both equal to, that tells us when we graph these points, they're going to be closed circles. So I like to put that next to my table to remind me. If the equal to wasn't there, they would be open circles on the ends. All right, now I could go ahead and graph that, but I do like finding my table for my other function as well, because if I have to change my scale, you have to do it before you graph anything. So let's take a look at this function number 2. What you want to be able to do is identify what it is. Well, here we have an x squared. X squareds are quadratics, or their graphs are parabolas. So it's good to know what it is that you're graphing, because you're not going to graph the whole thing, but just a piece of it. So let's see, this one says we're going to graph x is greater than 1. Now, even though 1 is not included, it's still where we start on our graph. The only thing that, since it's not included, tells us that we're going to have an open circle when we graph it. And then we need numbers that are bigger. X is greater than 1, so bigger than 1. 1, 2, 3, 4. We're going to substitute each one of those into this equation. 1 minus 3 squared, and then that negative, plus 5 gives us 1. 2 minus 3 squared times that negative plus 5 gives us 4, 5, 4. Now, those of you that are familiar with parabolas, this form here is vertex form. So we can see that 3, 5 is our vertex, which also happened to show up on our table. But that's a really important point on our graph and for parabolas. So something to think about when you're graphing parabolas. All right, let's graph each one of these. So we have the point -2, -5, -1, 3, 0, -1, 1, 1. And that's a line, but it's been cut off. So it's actually only a segment. We're not going to continue it past that. There's no arrows because it's only going from -2 to 1. Now we're going to graph the parabola part. So 1, 1 would be here. It says a point is already there. Now it was supposed to be an open circle, but if there's already a closed circle there, closed supersedes open. So we actually don't even have to worry about putting an open circle there. Then we're going to go to 2, 4, 4, 3, 5, 4, 4. Oh, so this looks like it's going to be upside down parabola, which I hadn't paid attention to before, but that makes sense because there's a negative on the outside telling us that it's going to open down. So that's why it's kind of helpful to know these things, or transformations and what it looks like. So we're having a parabola that opens down. It starts here at 1. Going to loop all the way through. And this one didn't have an ending, so it's going to get to keep going with an arrow. It had an ending on this side, so this left side's not going to have an arrow, but the right side is. Okay, so after we get it graphed, now we want to find the domain and range, which I always think is easier when you have a graph to look at. So domain is the x values. So on our x-axis, we kind of slide over. We can see that we're starting our x-axis at -2. And as we slide over from the right side, this one, it does look like it's going down, but at the same time that it's going down, it's also going to the right. So it's going down and to the right forever. So this is actually going to go -2 to infinity. And then range, we always do bottom to top. So if we start at the bottom, it looks like this bottom number would be -5. However, this arrow continues down forever. So since it continues down forever, it's going to be -infinity. And then the top does stop at 5, the bracket. All right, so that's a piecewise function. I'm going to show you another one. I want you to write it down, give it a try, and then come back and see what pieces, you got right. So hit pause and see what you can do. All right, so when I look at this one, I look at this first equation and I note that it is an absolute value. And I know that absolute value graphs typically look like a V. So I'm going to keep that in mind when I'm graphing. It needs to look like a V. When I make my table, I'm going to look at my domain. It says x is less than -1. So I start my table at -1, noting that at -1 it's going to be an open circle. Then I want some numbers less than -1. So -2, -3, -4. Then I substitute those in to the absolute value. Remember, absolute value always comes out with a positive answer. And now I'm going to look at my second equation. So this equation here is a square root. Square root graphs are the ones that look like sideways half parabolas. Again, I always try to think about what does it look like before I graph it, so to make sure my graph turns out correctly. All right, so when I make my table, I look at the domain. Again, it's starting at -1, but it's a closed circle. And these numbers are getting greater than -1. So 0, 1, 2. I'm going to put those into my equation. Some of them turn out to be decimals. That's okay. Okay, so when I go to graph this absolute value, I'm going to graph the points -1, 3, and that was an open circle, -2, 4, -3, 5, -4, 6. All right, now that to me looks like a line, but I was expecting a V. So I want to kind of check on some things here. Absolute value, the transformation that happened here, looks like it was a V that went to the right 2. So that would have put my vertex, if it started at 0, 0, my vertex would have then moved to 2, 0. So my vertex, if I were to continue this, would be down here. But because of this domain, it starts way over here. So this vertex would have been where the other part of the V was. So you can kind of see how we're not getting the full V shape on this one that we should. So all we get on this one is just this ray that's continuing. So it doesn't really look like a V at all. Now the next one, the square root, we're going to graph -1, -1, closed circle, 0, 1, 1, 1.8, and 2, 2.5. Whoops, I graphed 0, 0 instead of 0, 1. Zero, 1, 1, 1.8, and 2, 2.5. And then I want to connect those to make that curve that we were looking for. And I have my 2 pieces. All right, so let's talk about domain and range. Domain is our x values. It looks like it's going to continue moving forever to the left and forever to the right. So domain is -infinity to infinity. Range is the y values, so our bottommost y value looks like it's going to be at -1. And then it's going to continue going up forever, so that goes to infinity.